I was given this by my grandfather when I was about 7 years old. That would have been about 1969. And I played with it a lot till I wore it out completely and it stopped working. And then I attempted a repair on it about 25 years ago, just to show my daughters something. But that repair was only done with carpentry and plumbing tools and such as I had at the time. So it still has its original burner, doesn't have its original presentation case anymore, so we'll have to do away with that. But even with the old repair from 25 years ago, it will actually run in that condition. I actually used a cabinet door bolt to make a cylinder, and an old screw and whatnot to make a piston, but I had to add a extra crosshead on top of the cylinder to make it oscillate, otherwise it wouldn't run. But it did go, and maybe it's time to improve it a bit more. Now, when I was a kid, I also let this run dry, and it overheated and the boiler completely melted down, and Grandad did do some repairs on this, but it's rather brutal soldering on the chimney and the end plate of the boiler, so the soldering will have to be repaired as well. Because I've lost all of the original parts, I have lost track of all the geometry and dimensions that this thing is supposed to be, so I've modelled it up in 3D to make sure that I can get the cylinder the right length, or long enough to make it oscillate, get the piston long enough to make it oscillate, and set the length of the com rod and the steam port in the right place so that it can actually receive some steam when it's at top dead center. The steam port hole, that's going to be fixed by the existing manifold block that's on the engine frame, and the pivot point is set by the engine frame as well. So those dimensions I can copy off of the frame. I've actually broken the pivot screw, so I'm going to have to make a new pivot screw, which doesn't upset me too much because I can make it in a metric thread. But from this model I made up some drawings of as required dimensions to make these parts: new cylinder, new valve block, and a new piston and com rod, with whatever bits and pieces I can bring together. I'm using a 5.5mm radius gauge here to make a concave feature that will receive the cylinder once I make the cylinder. The cylinder is going to be outside diameter 11mm. If I'd have been smart about it, I could have made it 10mm or 12, but it really would have been too thin or too fat. But an even number of radius would have allowed me to just plunge down there with an end mill, but that's not how it went. So boring head, gradually scooping out an approximate radius to be able to solder in a cylinder once that cylinder's been made. This is the same valve block, having made the concave feature. Now turn it over on the back and bring it down to thickness, more correctly thinness, so that this will set the cylinder at the right offset from the engine frame so that it will line up with the crank pin properly. It's a bit of a blunt end mill that, but I'm running it fast and taking light cuts because it's such a soft piece of metal and I've not got much of a grip on it in the vice there. So taking it gently, not wanting to damage it. I'm tapping the pivot screw hole all the way through the block. The cylinder will get soldered onto one side of it eventually, which will end up making that a blind hole. a blind hole with some solder inside it, so I don't know how deep that's going to be, which means I've just got to make the pivot screw to an as-fit dimension rather than predetermined. The steam port hole hasn't been drilled yet, that's been marked, but I'll drill that steam port through the block and the cylinder once it's all soldered together, guaranteeing that they'll line up. So I'm reaming the cylinder to 8mm, and in hindsight I really should have bored it with a boring bar. The finish from this wasn't great, but it's good enough for a toy. So with the cylinder bored to what I think is the correct depth, I've now got to cut the cylinder off, and it's in this operation I find out, or have it confirmed to me, that the carriage dial on this lathe is nowhere near accurate. If I was to try and stroke that along 40mm, it would actually only move about 39. So for one reason or another, I'm about to cut this cylinder off 1mm short. Now, brass really is such a joy to machine, it's just so easy, it's like chalk or cheese. But as this parting operation comes down towards the part actually coming off, you're going to notice that it leaves a much larger nub on the end of the stock than it should do. The piece falls off sooner than it should. And the reason for that is that the tool has actually broken through into the drilling of the cylinder, which means I've got to remake that part all over again. Here we have a piece of old threaded brass rod, and using a collet block and forming a 5mm hexagonal feature, probably about 15-20mm down the length of that rod, so that eventually that's going to become the head of the pivot screw. I need to turn that down, put a thread on the end and part it off to make the head of the screw. So despite its rather ghastly appearance in the previous clip, bringing the end of that rod down to 3mm, so that it will take a 3mm thread, probably about halfway up it. Now I don't know what the length of this screw is going to have to be at the end. I'm just going to make it as required, as all the parts fit together. But I do need to get that down to 3mm. To make this screw fit properly, it was just a matter of increasing the length of thread along the screw, testing it as the parts go together, and then shortening the screw, putting a bit more thread on it as necessary, just to make sure that it bottoms out in the hole and it sets up the correct distance between the screw head and the valve block. The valve block and cylinder are now soldered together, and that hole has become a blind hole, but I'm not really sure how deep it is. I've just got to make sure that the screw bottoms out in the bottom of the hole, because that's how it's going to tighten and stay in place. But the distance between the valve block face and the head of the screw is somewhat critical, because that's what holds the whole mechanism together. Now I didn't record any of the cleaning and painting of the various parts, but all of the boiler got desoldered and taken to pieces, cleaned up and resoldered back together. So the chimney there needed some dents knocked out of it, as did the boiler. That barrel band there, that just needed turning over because the inside of it was clean and shiny. Leather washers for the safety valve and the whistle as well. They're supposed to be rubber, but I'm not sure how that's going to work. Made a little chain for the whistle and a bit of key ring. Cleaned up the level plug. Resoldered the end plate onto the boiler itself. That firebox actually got boiled to convert all the rust off of it, and spray painted with barbecue paint. The original boiler just got itself wire brushed and put back together, painted. That turns into an instant mess as soon as you use it, so that's not going to stay clean for very long. Things got taken apart and had to be put back together with screws instead of rivets, so it's not as original, but it's back together. That pulley got left well alone, didn't want to mess with that. I didn't record much of the making of the piston and rod and connecting rod end because it's just turning cylindrical parts. But there's the old pieces. Like I say, I'd made that out of a cabinet door bolt and a steel bolt to make the piston, but the piston was never long enough to be able to oscillate that cylinder. So that meant that I had to add that crosshead to the top of the cylinder to make the thing oscillate and wobble so that it would work. It did work. But of course it's nothing like it should be. So I had a new screw, a new valve block, new cylinder. Needed to set the piston in situ in the right place according to where the conrod was going to be. And relied on the 3D modelling to get the steam port and piston top dead centre in the right place. Now I have the clock in the background there just to keep a record of how long this takes to fill up, fire up and then run. I did want to keep the camera running until the engine completely stopped or ran out of fuel, but my camera only records in 17 minutes limits, and it was still running after that. So I'm filling it up there, admittedly with already fairly hot water, just to save time. Fill it up to the level plug, put the safety valve back in. This is methylated spirits, what would be called in the US denatured alcohol. This is the stuff they deliberately poison to send you blind if you dare to drink it, instead of paying tax on alcohol that you pay tax on. Now, as a youngster I used to fill this thing right up to the brim so that it was swimming in the stuff, but it really doesn't achieve anything. So just until the wadding is sodden, yeah, that's enough. Now I'm going to use 3-in-1 oil on this, which turns out to be probably the worst oil you can use. Once it gets hot and once it gets water on it, it just seems to evaporate and disappear. So not the best oil by any means. And the thing about methylated spirits is you can't see when it's alight, so just test it to see if it's alight, but make sure you don't burn yourself. A better oil for this would have been something a bit heavier. I've got some CT90 cutting oil which I've used on it since, and it seems to stay on the parts after a run without dissolving away or evaporating. So there are proper oils for this, but in all the time I've had it, I think I've only run this 3 times since I did this. So from putting the burner under the boiler to it actually running only took about 3.5 minutes. The water in the boiler was already quite warm to the touch, so it did take a little bit less than it normally would have done, but I think that fired up pretty quickly. It's not running very fast because the pressure wasn't so high, but a few minutes later it's really picking up speed and starting to dance around on the bench there. So that's actually running forwards. The frame rate is making it look like it's running backwards. Now I ran this a few months later when I had a tacho, just to see how fast it does run normally, and it's around 1900 to 2000 RPM. Depending on the pressure. It tends to go up and down as the pressure rises then falls. If you use the whistle it slows down. About 2000 RPM, I can't see how a thing like that can run any faster. Now my camera doesn't record more than 17 minutes, so the camera stopped filming before it eventually stopped, but it ran for around 15 minutes. And it whistles.